Okay guys, so for this one we're going to be finding the fraction of atoms in a sample of strontium that would remain after 175 years. Just some important stuff to note. It's just that we're talking about the half-life of strontium is going to be 29 years. Okay. Now for the first part, this is the equation that we're going to be using. It's ln of over the initial moles, and that's going to be equal to negative kT. Okay, so our first thing to find kT is going to be, let me see, so our K, this is actually going to go ahead and be, this is going to equal 0.693 divided by our half-life, and that's just like we set up here. It's going to be 29 years. Okay, and then we're going to go ahead and calculate that, and that's going to come out to 0.024 years. This one. Okay, let's just make sure that's important to note. Okay, so now that we have K, we go ahead and make sure we have everything else. So let's go ahead and look at that. So for M, that's what we're looking for. Our initial, it's going to equal 1. Our T, as we stated, was 175 years. And then our K, as we just found right now, equals 0.024 years. Okay, now that we have that, we can go ahead and plug all this stuff in up here. And that's going to just go ahead and plug in nicely. So we're just going to go ahead and write that up now. So it's going to be the ln, like we said, we don't know what m is, so we're going to leave that there, divided by 1. This is going to go ahead and equal negative, because of course it's negative up there in our equation, 0.024 years, this one, and this is going to be multiplied by the time, which is 175 years. This is, when we calculate all this on this side, it's going to equal negative 4.2. Okay, an important note. Okay, once we have all this, we're going to try to get everything by itself. So we're going to try to get our m by itself. So we raise the e to the log of m over 1. So that's basically going to cancel this out right here, and it's going to go ahead and just leave us there with our e. Okay, so it's going to be m over 1. And then this is going to go ahead and equal e to the negative because of all this. So right here, this is coming over here because we're raising all that. Okay, so it's going to be e raised to the negative 4.2, which is going to equal 0.015. And in actuality, that is our answer for this problem.